hello, everybody. So today I'm talking about supersets. I've been giving superset talks before, but this one I try to take a different angle a little bit. So usually I run a demo, and usually I talk mostly about what superset is and whether it's relevant or how it may be relevant for you and your organization. Today I'm talking a little bit more about the history and about like how it came to be and some of the decisions we've made over the period of time in which we've built this community and this tool. So you probably use a lot of open source software, and really often you have just no idea of what's behind this open source software, like what are the faces and who are building these things and what they go through as they grow this software. So I'm trying to address some of this today. Before I get started, a little bit about me. So that's the slide I get to reuse all the time. So at this point in my career, I'm mostly known for the work that I've done around Superset and Airflow. We won't be talking about Airflow here today, at least I won't be. We'll be talking about Superset. I'm a digital artist, which is not something I would bring up, but I think it's relevant to talk about this in this context because really, for me, when I was working at Airbnb on Airflow, when I started working on Superset, that's really where I started to kind of where my hobbies, where after hours and in my hobbies, I was playing with electronics. I was doing interactive art installation for Burning Man and things like that. So I was writing code for the pure pleasure of it and for just generating images and things that move and that are interactive. So when I started working on Superset, I really kind of found where my career started meeting my hobbies and my passion. So I've been full on over the past 4 years or so. I think we're coming close to 4 years working mostly focusing on Superset. I've been doing a lot of work in the data engineering space up until 2015 or 16. Mostly my major contribution was probably Apache Airflow, or starting the project at least. And last year I was here talking about different aspects of data engineering that are dear to me. One was this idea of applying concepts from functional programming to data engineering. So still an area of interest to me, but right now I'm really focusing on data viz. I've been doing data for a long time, and more recently I left Lyft to go and start my own thing, which is still in stealth mode, so I'm not talking about this today, but I'm happy to talk to people about that offline. So before jumping into the history of Superset, I want to make it kind of clear, and I'm not sure how many people in the room are familiar with Superset. So how many of you I've done a little bit of research on Superset already? Wait, I lost my mic. All right. So it's probably a good thing if I do start by just kind of showing what it is. So they say an image is worth 1,000 words. So here we got right about 4,000 words here, and I've got kind of zoom in of the different apps that are in Superset. So really, Superset is a collection of 3 apps that you can navigate from and to. The first part is this dashboard view, where you can consume dashboard, you can create interactive dashboards, and set them up and organize your dashboards. The second app, so from the dashboard view, you can easily get into this, what we call the Explore view. So this is web form-based approach to slice and dicing. So it's a mix of slice and dice, explore your data from here. You can easily kind of pivot to different data visualization that we support, right? And do a little bit of publishing here too, things like, do you want to show the legend? Do you want to adjust the size of things? So really this slice and dice view is a mix of data exploration plus publication, or making your visualization look exactly like you want it to look. Come on, clicker, don't let me down. All right. So the third app inside Superset is this SQL IDE. So it turns out it's pretty useful if you are doing data exploration and you know SQL, to have access to SQL IDE. For context too, Superset is very much of a web application, and it's a full-on product that you're installing in your organization, given access to people too, and a place where people, it's really a tool full-on in the category of business intelligence or data visualization. So very much a competitor with tools like Tableau, Looker, and the plethora of tools in this space. The main differentiator here is that Superset is open source, and we're the Apache Software Foundation. So very much an open source project around visualization, but a product as opposed to a data visualization library or something like that, right? So I think a lot of the open source projects we have around are expected to be composed into applications. This is an open source application, so I wanted to be clear on that. So this is like our semantic layer. So semantic layer is the old term that business objects and MicroStrategy and perhaps like Looker are using to describe the layer that what the business intelligence product like knows about the physical database and extra information on top. So I think historically semantic layers have been very heavy, right? Like where before doing a visualization on a table, you would have to add your table to your semantic layer and do a lot of upfront work. So there's trade-offs here. So if you do a lot of upfront work where you inform the system about the table you're bringing in, you're creating your metrics and your calculated columns, then it presumably makes it easier for people down the line to come and self-service and use this tool. In our case, we wanted to make it really easy for people to just point to a table and be able to leverage it right away and kind of get the semantic layer more as an afterthought or something that you add on top when you're ready for it or when you need it. And I think that brings this, it links nicely with this idea. So one of the philosophy or principle behind Apache Superset is this idea to have like a very fast time to dashboard. So assuming that you have a data set that has like dimensions and metrics and you want to visualize what's in there, we want to get that semantic layer out of your way and just get you to create this dashboard very quickly. It is enterprise ready, so that means that we have role-based access control. We know who can do what in the application and who can access which data. I think it's very important in this space, right? If you have a tool in the data exploration space to be able to control and audit and like who has access to what and who can do what. It's also cloud native. I'll talk about that in a slide that's coming up. We support a lot of visualization. That was always a premise. When I started the project, I really wanted for Superset to take like all the awesome work in D3 that was done at the time, to commoditize that and make it accessible to people. So you could take any data from any database, any visualization from the visualizations out there that exist, and bring these things together. Off of these 50 data visualizations, some work very well, like the common ones that are used all the time, the line charts and the tables and the bar charts, the pie chart, all that stuff is like super fine-tuned. And then there's a long tail of visualization that also work, but that might offer less options or are less rich in some ways. I think now, so we recently pluginified the visualization, so it makes it a lot easier for people to go and create their own visualization. That's still work that's on the way, but we're really excited to open that up. And see if you work in genomics or if you work in ML, maybe you can contribute some visualization that are more specific to your use cases and share them with our community. Lightweight semantic layer, I talked about this, right? So not in your face, you don't have to think about it up front. You can later on go and inform your calculated, your more complex metrics or calculated columns, but you don't have to do it up front. We work with pretty much every database out there that speaks SQL. So we use this library called SQL Alchemy. That's a Python library. And this library is not only an ORM, but it's also a SQL toolkit that the ORM is built on. And this allows us to basically write SQL in an API that can be translated to different SQL dialects. So we have this deep integration with Druid. I'll talk about like kind of the founding story, like how the project got started. So originally we were just a front end. This project started. It was really just a front end for Druid. So historically we've been kind of growing with them. Druid is now an Apache project too. So we make sure that these things work well together. And Superset's got this like nice, thriving and growing open source community. So the early days, so I said this talk was going to be a little bit about the history and how we came to be, and I think that's relevant for people that are now contributing to open source or looking at maybe starting an open source project to kind of understand and get a sample maybe of how open source projects come to be. So the context in which like Superset got started, and we went through different names over time, but originally, as I said, I was at Airbnb. I believe it was summer of 2015. And there was going to be this 3-day hackathon. So I was heavily hacking on Airflow at the time. I had been for probably 9 months or so. And I was like, I need something different. Like, I want to do something different for a hackathon. And we had people on the data infrastructure team that were running a POC on Druid. And personally, I was just super excited about Druid and what it could do. So Druid is this database, and I'm not going to get into a lot of details about what Druid is because people might be already familiar with it in this room. But I'm going to talk about it a tiny bit. So Druid is a real-time database that's an in-memory column store, distributed, and it allows, for us at Airbnb, it allowed us to scan a huge amount of data very quickly. Right, so you could get into the tens of billions of rows that you can scan in less than a second or so, and real-time data, which at Airbnb at the time, there was just Presto and Hive, a little bit of HBase for the vital real-time needs, but we didn't have this like multi-dimensional time series database that Druid is. So there was this great opportunity. I was also out of Facebook at the time, and if we have ex-Facebook in the room or people that have talked to ex-Facebook, you've probably heard about the technology called Scuba that they have internally at Facebook. That's also an in-memory real-time column store with that can answer queries very quickly. So I wanted to recreate a little bit the Scuba experience. So Scuba at Facebook offered a backend and a front end that worked very well together. Here we had Druid, that was this awesome database, very much like Scuba, without any open source GUI on top of it. Druid did not speak SQL at the time. It now does. So I was like, this is the opportunity to go and create, this Explore view. We can slice and dice data out of Druid and open to all sorts of new use cases at Airbnb. So that's where it came to be. After the 3-day hackathon and after perhaps like nights and weekends, we had something pretty solid that was fun to play with. We had people internally, that were getting excited about the promise, the things we could deliver with this. On the other end, though, we had like a little bit of a near-death experience with the project because Druid was still in a state of like alpha or just POC internally at Airbnb, and we didn't know whether there was going to be the database of choice. There was Pinot at the time. That was very early for Pinot, but it looked interesting. And there was other things we could do with Spark streaming and HBase to solve some of the real-time use cases we had. So there was a little bit of do we want to push this thing forward or not? So over a weekend, since the database of choice we had was Presto there, I was like, let me try to make what I have working now against Presto too. And while I do this and while I write, the SQL query, like the SQL engine, I'm going to try to make it work with all SQL-speaking databases. So that's how we came to be. The name changes are mostly because Panoramics is the name of the Druid in this cartoon called Asterix. That's a Belgian or French cartoon. So apparently there's a company somewhere in the world named that, so we can use that. And then Caravel, we decided to move away from because of its ties to colonization, and it evoked like negative emotion in some people. So we're like, okay, once you see it, you can't unsee it. And that's where Superset came to be. Hardest problem, naming things, right? I think a year or so, or a little bit less, I think it's a year and a half in the life cycle of the project. That's, I would say, a year or so, a little bit more than a year, is where Airbnb committed to using Druid, and we decided to create a small team around it. I saw Bogdan earlier, who was an early member of the team. So we decided to create a team of 4 engineers, put a PM, and start pushing Superset and Druid forward. And people at Hortonworks heard about this effort. They were interested in packaging Druid, Superset, and something called StreamSet into their Hadoop distribution. So they reached out to us and they're like, hey guys, we would love for your software to join the Apache Software Foundation. We can help you to do that. And the Apache Software Foundation is great. You should do that with us, and we're going to provide mentors and champions and do all the paperwork that is required to join the Apache Software Foundation. So I think they had really good intentions at the time. They never really turned out, so we're still incubating the Apache Software Foundation. I would say for people not familiar with Software Foundation, or more specifically the Apache Software Foundation, it's an absolute great thing, right? As someone who's interested in using a piece of open source software, if you see that the stamp Apache, it's great from your perspective because you know that the piece of software or the project has a governance model that is fair, and that provides a set of guarantees that you probably want as a user of an open source project. For people like me working on the project, that means we have a little bit more paperwork. We need more rigor around things like release cadence, signing releases. There's paperwork that we need to provide every quarter. We need to make sure that all the licenses we use are vetted for. So it's all great guarantees for users and extra work for the founding team. And a lot of the engineers working on the project are not that interested in doing that work. So pros and cons here, but glad we joined the Apache Software Foundation. This is the slide about just the project and looking at some of the open source metrics, so things that you would see on GitHub. So we have a lot of stars, which is a good thing. So I think it proves that there's really an interest out there, and the people in this room, just your presence probably shows that people are interested in open source in the data space up the stack, right? In the data stack, open source has really conquered the data stack and at the storage and compute level, stream computation, right? Everything's open source. I think there's definitely a subset of the people that and the teams out there that are really interested in going full stack open source for obvious reasons. So we have this growing community. This is a proven project that has a lot of users at Airbnb and Lyft and at these companies under here. And we have a lot of very committed engineers working on this. So it's only going to get better from this point. One thing that I don't always, or that people don't necessarily get too with open source is that yes, we're a dozen people, and yes, that's a very small group of people to compete with the vendors out there, but we use literally, when you look at our dependency tree, I'm going to talk about the dependency tree that we have on the Python and JavaScript side. There's literally hundreds and hundreds of contributors behind the scene that are working on packages that we use. Of course, vendors can also use these packages, but we're really, when you look at some of these top level open source project, we're an army of people working on these things. So the stack that we use, so it's mostly just JavaScript in the front end, Python in the back end. We move all the code to React and Redux, I would say 3 years ago. When I started the project at Hackathon, I was extremely bad at JavaScript and using jQuery and doing all the things that you probably shouldn't do anymore. And we've got none of that anymore. So learned a lot on this project. And I think while Superset has been growing up too, so is front-end engineering, right? Front-end engineering has been completely changed over the past few years. And we've been kind of riding this wave. I could have done a talk on just a JavaScript build pipeline that we use. So we use tons of libraries. We're dependent on so many things, right? On the data viz side. And at some point, our JavaScript bundles were so big, they were 20 or 30 megs. So we had to really use some of the latest technology in the JavaScript world around Webpack to split our packages and be really creative about how to load up these packages. So NVD3 data UI, VX, blocks, right? So for the visualization code, really the common denominator here is JavaScript. So that means that if you have JavaScript code that can take data and visualize it, you can write a data visualization plugin for Superset. On the backend side, we're in Python, and we're very glad to be. I think there's some things that are really advanced in Python that you really wish you had in other languages. Things like pandas, right, to do all sorts of pivoting and time series and window functions and all sorts of data munging. It's really instrumental to get the data that comes back from the database into a pandas data frame. It's a great place to pivot things around and do all sorts of transformation. By the way, I did not really get into this early on when talking about just Superset. I think it's important to mention that Superset does not store data in any way, right? We do all of the heavy lifting on your data warehouse. So we assume that users of Superset have made large investments in their data warehouse, things like BigQuery, like Redshift, and we push down as much of the compute and aggregation as we can down, right? So the pandas layer is we get aggregated data, and we'll do simple transformations on that. SQL Alchemy is also I mentioned it earlier. It's very instrumental to have, right? This is our magic on how we can talk to all the different SQL dialects, and no one would want to write this code, right? Of saying, hey, if it's SQL Server, I'm going to write select up, or if it's MySQL, I'm going to use a limit clause, or this sort of thing. So it's been great to have both the power of the JavaScript community and the power of the Python community. I'm not getting into the bowels of Superset where we'd be looking at the internal of Superset, where we'd be looking at really what it's made of in terms of libraries. But in Python, we have access to tons of little libraries that help us very much. So this is probably the slide that took me a little bit longer to make, a little bit more involved. So this is what the architecture looks like for Superset. So one thing that I've done working on open source projects, and Airflow was very much like that, I wanted to make it super easy for people that just want to get started to get started and to not have to set up a bunch of infrastructure. So in its simplest form, Superset is really just a web server and a metadata database. And I talked about cloud native earlier, or I used the term. Idea being that we support standards and abstractions. We use abstraction that allows you to use your preferred stack and technologies to run Superset. So that means our metadata store is behind the SQL Alchemy abstraction. So that means you can use MySQL, Postgres, MariaDB. If you're more adventurous, you can use things like SQL Server and Oracle too, right? The fact that we use WSGI, the standard in Python for web servers, you can use Nginx, Apache Web Server, GUnicorn, so you get a bunch of choices. Similarly, if you decide to set up the cache layer for Superset, you have the choice to use Redis, Memcache, or even implement and extend your own caching engine. For clarity, I said Superset does not store any data, right? So we don't have this concept of cube, Tableau has these Tableau extracts, and some other tools that will have a way for you to export the data into some proprietary, duplicate your data into their own cube or their own storage layer. So here, the only data that we can store, if you decide so, right, if you configure Superset to use a caching layer, is the cache that is behind each chart. So you can imagine when you look at one Superset visualization that behind the scene there's a JSON payload that contains the data and some metadata about the chart. That is what we store in the cache. And the UI is very upfront too about what is cache and what is not, and when the cache was taken. And it allows you very easily to force refresh just about anything. Now, I had to include, this is not part of the architecture of Superset, but of course, we query all of these databases here. So if your database speaks SQL, very likely that we can query it easily, right? There's still a place in Superset where we need to add a little bit of a layer to deal with the fact that these different databases are different. So for things like time functions, right? So if you're trying to aggregate by day or by week, or things like subtleties around how databases handle their cursors or their pagination interface, right? So there are ways that we can implement some method to deal with the fact that not all databases operate the same way. Here, so the async part of the infrastructure exists to deal with the fact that a lot of so web servers are expected to run, or a web request typically is expected to time out at about 30 seconds to 120 seconds, right? And we do know that a lot of analytics type queries are going to last a lot longer than this. So we use Superset to query things like Hive and Presto and Impala and Redshift. And it's not uncommon to have queries that will last 5 minutes, 10 minutes. And if it's Hive, like who knows how long it might take, right? So in this case, if you want, so one option you have is to take your web server and say, like, I'm going to crank up, the timeout on it to like 5 minutes, but that's definitely not good practice. So to deal with this fact, we allow to set up this optional async infrastructure where the web server is able to send a message to the queue, and then we have this array of worker that can monitor these queries for you and update the database so that seamlessly behind the scene, we can have long-running queries that still work. I've got a clicker that works 1 time out of 3, I think. Maybe I'll use this arrow here. I want to talk about challenges. So far we've talked mostly about the past and the present, and I think it's relevant to talk about, when talking about an open source project, of like where you're at and what are your current, challenges. So here I'm going to dig a little bit into this and talk about the challenges we're facing. So the first one is, there was a time where most of the commits, like in the first 3 months or year of the project, I think I was the main contributor and I knew everything that was going on. Over time, we grew to have hundreds of contributors, and this is GitHub Insights over a period of a month, right? So 4 weeks or so 74 pull requests. There's a lot of people contributing. I know most of these people, not all of them, right? And no one, when you get to a certain point in your open source project, not any one specific individual knows everything about everything that's going on. So it's like distributed knowledge, and that can be really challenging to deal with. For all sorts of reasons, people have different roadmaps, people have different ways to contribute, people agree, disagree on things. We don't really have an issue around consensus as much as just pace, and keeping up is hard for anyone working on the project. And I assume that this is nothing compared, right, the Linux kernel project, right, where there's so many commits that they had to build their own infrastructure, and they had to build Git itself to deal with the fact that things were so fast-paced. Another challenge that we have that I alluded to is the fact that we have this gigantic dependency tree. There's this trend in the JavaScript world that you're probably aware of that is micro packages. So sometimes when you import a single package, like here, it's written really small, but this is Babel CLI, which depend on something, which depends on a whole array of things, and it's just this gigantic tree. That is the nature, I think, of JavaScript development to a certain point these days, but it does bring challenges. All of these packages are evolving at different pace, sometimes too slow, sometimes too fast. Luckily, NPM is a really good package repository, but still, right, behind the scene, we're juggling with a lot of moving parts. We can pin these moving parts, but it's still challenging. So in terms of scale, right, 88 production packages and 68 dev packages is kind of extreme, and that's not common to a lot of applications out there. It's kind of an extreme case here. And when you look at the leaves, right, so these are the number of top nodes in our tree, the thing we depend on. These things depend on other things, and we get to above 1,000 individual packages that we depend on. Fun stuff. Welcome to the JavaScript world, right? And in Python, it's less extreme, right? We have 35 direct dependencies, and that leads to 66 packages. But behind all of these packages, there's someone or multiple people and a history of changes and backward and compatible changes. So that's definitely a struggle. This is not the merge tree. This is not the Git representation from our repository. This is just like me doing image search to find a complex one. But release management becomes really hard as you get feature branches, you get different releases, you get a lot of people that want different things. So coming up with a stable release is probably the hardest thing. It's easy to get people to contribute. It's hard to get all these contributions into a cohesive release. And release management is not the sexiest thing. So you know, not a lot of people partake in it. So it becomes a job of like keeping up with everyone and getting all the contributors to pitch in and help out with releasing. So we're working on our first official signed Apache release at this time. Apache very much like pre 1.0 still, but I think we're on a clear path to steady Apache releases, solid releases, getting to 1.0, like lifting the quality bar and maintaining it at that level. Oh, I think I skipped one. Coordination, a lot of people means coordination is a challenge. Luckily, we've got all sorts of tools to communicate, things like a live Slack, the dev mailing list. Apache, you know, offers help there too. We use GitHub. We have physical meetings, so we meet between the people at Lyft, Airbnb, Twitter, and Apple. You know, like we get together once every 2 weeks and talk about, you know, everything that's going on in the project. Really, I try to keep everyone in sync and everyone aligned. And often trying to get people to do I think what's on the next slide here, which is like dealing with some of the paperwork and things that are less fun to do. So the Apache Software Foundation requires us to do a certain number of things, and you know we need to coordinate to make sure these things get done. So I'm going to talk a little bit about the roadmap here that's ahead of us and things that are actively getting worked on. So steady Apache-approved releases. So that's going on now. Quality and polish, there's this like, so Superset started as a hackathon project, as I said earlier, right? So now we need to like grow up from hackathon to, you know, beta at a lot of big companies to ultimately something that's like really enterprise grade and something that people love to use and are delighted with. So that means like less bugs per million interactions. That means things like just polish and better like key user flows that work very well and that are intuitive. We're working on like thumbnails and cards, so that means it's not super trivial, but for each asset, for each chart and dashboard, we should have little thumbnails so that we can have visual representation of list of charts, list of dashboards and things like that. So that's really like for visual appeal and like, you know, just being able to visualize the assets that we have. We're also working on embeddable components, and so basically the idea being that the building blocks of Superset we expose for people to build other things like data products. So I know there's another track, I think, in a different room talking about building data products. I'm hoping that, you know, maybe next year I'm in that other room talking about how you can use Superset to power data products. So one big component of that is the data access layer. So Superset internally uses APIs to talk to your different databases. So it receives kind of multi-dimensional queries, like queries that are either SQL to power the product that I mentioned earlier that's called SQL Lab, right? So there's an endpoint that you can send SQL and receive data. There's another endpoint that you can call with dimensions and metrics and filter objects and receive data as well. So here we want to expose that. And exposing that, you're like, what do we really get from a data access layer? Well, you get things like authentication, permission, right? Can this user access this resource? You get things like audit of who queried what, when, and you get caching too, right? So if you Superset knows how to do caching, so that means if you're building a data product, instead of writing a backend that knows how to query different databases and craft queries and do like auth and perm and caching and auditing, well, you can just point, assuming that you have a superset backend in your environment, you can just use that. Embeddable components is building upon that, so it's a set of React components and a superset client kind of wrapper React component that allows you to craft or make it really easy for just anyone to add visualization to their data product or web application. And the goal there is to have full-on interactive components that you kind of just drop in your app. You don't write any backend code, and it's just super fast, and you can get up and running quickly, adding interactive data viz component to your apps. Schedule simple data pipeline. There's people at Lyft working on this. This is very simple. Don't think about it like an Informatica competitor. It's really just you're in SQL Lab, you're writing some SQL, you would like to schedule something to run every day with a few simple dependencies on other resources. So we want to make that something you can do inside Superset. So what's next, right? So given the positioning that we have, right, and we have this backend, we have this service that does a lot of things already. There's so much we can do, and I'm running out of time. I think I have a few minutes. I have 2 minutes. I'm going to get into these, but I think any one of these points, I think are interesting in their own right, and we could talk about. But personally, I've been really interested in the idea of automating the workload of a data analyst or data scientist and helping them out around root cause analysis, anomaly detection. Making a good dashboard is hard. It'd be great if we had some sort of wizard that, given a data set, would ask you a question about your key metrics and dimensions and time and timestamps in your table and help you, assist you into creating your dashboard. Mobile, of course, data governance and auditing, right? Defining who can give access to what. Integration with notebooks, I'm not sure, but that could happen, right? It seems like a relevant way that people are working with data. Storytelling, so here, there's so much we could do. Probably this is more interesting to alerts notification, right? Setting up some rules to get alerted with the right visualization when things happen. So conclusion, as I reach the end of this talk, so I'm looking to help, personally, companies on board. So I'm looking for probably a set of companies that are curious about Superset that would like to play with it. I'm starting a new company. But the goal is really not to sell you anything, is really just to partner up and understand how and help you use Superset and understand more about how it can be used in different places. If you're interested in working in Superset, there's resources here. But personally, I'm always interested in helping people, becoming part and growing the community. So if your organization or you as an individual want to onboard and be join this community, please shoot me an email. So that's all I got. Thank you very much.
Yeah, thanks for all your help with all this. I guess knowing what you know now, kind of having been through this experience, if you were to go back and do it again, how would you do it differently?
I love the Apache Software Foundation. But I might go with a different software foundation that is less opinionated on governance and how things should be run. I think they provide a lot of really good guarantees, and they've been helpful in general, but I feel like their governance model is too strict. So that's one thing I would do differently. I think for the rest of the approach of bootstrapping and building things organically, first joining a company like Airbnb or Lyft that really do sponsor people that want to work on open source software is really key, right? If you're interested in working in open source, join one of these companies. What are you doing working for a company where you can't open source your code? It's just too good of a career opportunity to pass on that. And then both my projects, Apache and Airflow and Superset, I started open source from the get-go. In the open from the first commit on. In this case, it was a hackathon. In the case of Airflow, I started the work in between my jobs to make sure it was going to be open source. And I would not do that differently. So that I'm a counter answering your question here, what I would do the same.